Hello, and welcome to Learner's Academy. In our previous lesson on basic linear functions, we learned that any straight line on a coordinate plane can be expressed using the general form of a linear equation, y equals mx plus c, where m represents the slope and c is the y-intercept. Today, we'll build on that understanding by introducing two important formulas that every student studying coordinate geometry must know: the formula for determining the slope of a line, and the formula for calculating the distance between any two given points on a plane. To begin this lesson, let's recall that in geometry, a straight line is fully determined by any two distinct points. For simplicity, we'll refer to these as point 1 as P1 and point 2 as P2. If we draw a segment connecting these 2 points, it represents a part of the line. By extending that segment infinitely in both directions, we generate the full line. Our aim is to determine the slope of the segment joining these 2 points and the distance between them. A key idea here is to visualize the line segment as the hypotenuse of a right-angled triangle formed by drawing horizontal and vertical lines from the 2 points. To form this triangle, start with the higher of the 2 points and draw a vertical line straight downward. From the second point, draw a horizontal line that intersects the vertical one. This setup produces a right triangle. The vertical and horizontal lines form the sides, and the diagonal segment is the hypotenuse. These two sides represent the change in the x and y values as we move from one point to the other. The horizontal side is the change in x, and the vertical side is the change in y. Now, saying change in x and change in y repeatedly can be cumbersome. That's why in mathematics, we use the Greek letter delta to represent the change. So instead of saying change in x, we say delta x, and change in y becomes delta y. Now let's see how we calculate delta x and delta y. To find these values, you simply subtract the x and y coordinates of the 2 points. If point 1 has coordinates x1, y1, and point 2 has coordinates x2, y2, then delta x equals x2 minus x1, and delta y equals y2 minus y1. Exam tip: always subtract in the same order, second minus first, to maintain consistency and avoid sign errors. These values, delta x and delta y, are fundamental because they are used directly in both the slope formula and the distance formula. Okay, the slope m of a line segment is the measure of steepness of the line. It tells us how much the y value increases or decreases when we move 1 unit in the x direction. Mathematically, slope is given by y2 minus y1 divided by x2 minus x1. This fraction simply means we divide the vertical change by the horizontal change. Sometimes slope is described as rise over run. Here, rise refers to the vertical change delta y, which is y2 minus y1, and run refers to the horizontal change delta x, which is x2 minus x1. Well, if the slope is negative, meaning the line goes downward as you move to the right, the term rise can be misleading, so it's best to use delta y and delta x. To find the distance between 2 points on the coordinate plane, we apply a formula derived from the Pythagorean theorem. We know that in Pythagoras' theorem, base square plus perpendicular square equals hypotenuse square. In our triangle, the base is delta x and perpendicular is delta y, while the hypotenuse represents the distance, d. So the formula becomes distance equals whole square root of delta x square plus delta y square. You'll often see it in expanded form where the delta x and delta y are written out as the subtractions, x2 minus x1 and y2 minus y1. Now, let's apply both formulas in examples. Suppose we are given two coordinates. Point 1 equals -1 comma 0 and point 2 equals 2 comma 4. We begin by calculating delta x and delta y. To help you visualize the setup, you can sketch the 2 points on a grid and connect them. To find delta x, we subtract the x value of point 1 from point 2. Delta x equals 2 minus -1, and the answer is 3. We're subtracting a negative here, so we actually add. Next, we calculate delta y. Here, delta y equals 4 minus 0, and we get 4. So, the horizontal side of our right triangle is 3 units long, and the vertical side is 4 units. That confirms what we would see on the graph. Now let's use these values in our slope formula. As we know, slope equals delta y by delta x. Therefore, we get 4 by 3, which is equal to 1 by 3, or 1.33 up to 2 decimal places. This means for every 1 unit you move in the x direction, the y value increases by 1.33 units. Now let's calculate the distance between the 2 points using the distance formula. By formula, distance between the 2 points equals whole square root of the sum of delta x squared and delta y squared, which comes out to be whole square root of the sum of 3 squared and 4 squared. The square of 3 is 9, and 4 squared is 16. Adding them up gives us 25, and the under root of 25 is 5. Therefore, the points are 5 units apart. Let's try another pair of points. Here we have point 1 equal to -4 comma 5, and point 2 equals 2 comma -3. Again, start by calculating delta x and delta y. Delta x equals 2 minus -4, which comes out to be +6. And delta y equals -3 minus 5, which gives us -8. Note that delta y is negative. This means the line is sloping downward from left to right. Remember, delta values can be negative because they represent direction as well as magnitude. Now use the slope formula. Here, slope equals delta y by delta x, which equals -8 by 6. This comes out to be -1, 1 by 3, or -1.33 up to 2 decimal places. So the slope of the line is negative, which is consistent with the downward slant we see on the graph. Now plug the values into the distance formula. As we know, distance equals whole square root of sum of delta x squared and delta y squared, which comes out to be whole square root of the sum of 6 squared and -8 squared. Solving the equation, we get whole under root of 36 plus 64, and the answer is 10. So these points are 10 units apart. In this video, we have learned how to find the slope and distance between any 2 points on a coordinate plane. The slope tells us how steep a line is, while the distance gives us the length between the 2 points. The formula for slope is m equals y2 minus y1 divided by x2 minus x1. And the distance between 2 points is equals whole square root of the sum of x2 minus x1 squared and y2 minus y1 squared. Always label your points carefully and be mindful of signs when subtracting. With regular practice, these calculations will become second nature. Thanks for learning with Learners Academy. Keep practicing, and you'll master coordinate geometry in no time.